Okay, what I wanted to do today is take our time and give you a video for estimating mechanically the square root. I felt like this was a bit rushed in class, which is in a way a compliment to you guys because you keep me busy. And our class moves right along, which is a lot of fun. I thought what would be easier is we're going to talk first. We're going to start with just the percentage of people who smoke in a state. Now, I do want to point out that if you click on this, and you'll notice that these are formatted as percentages, and that will sort of we'll work through as we do the problem a little bit. But they're really, if you divide them by 100, they're back to their natural proportions. So let's just do the bottom 12 states. And I thought that one of the things that would be interesting about doing it, there's a reason I picked the bottom 12, and I'd like you to try to just take a look at those 12 observations and see if in class you can tell me or share with the class why you think I picked the bottom 12 instead of the top 12 or any random 12, and I just did the wrong thing and hit paste where I didn't want it. Let's undo that. I wanted to hit copy. So if you two-finger click or double click then on copy, and I'm going to bring them up here and put it right here with paste. Okay, so now the first thing I need is the sum, is the average smoking for just these 12 states. So we'll call this average smoking. And that is equal to, and the command is sum, and we want to go from F2 to F13, and then we will divide that sum by 12. And that tells us, and now this is a good example. The average that you estimate is actually now expressed as a proportion because this cell hasn't been presented as a percentage. Just to clear this up and make it kind of easy, there's two things I'm going to do to format. One is to format everything into a percentage, although I'm going to do it just for columns F and G to begin with, and then I'll do column H a little differently, and you'll see why. So you go to Format, Cells, Percentage, and for the first two cells, simply 1 decimal point should be sufficient. Actually, we'll make it 2 so you can see the differences. That's one thing. The second thing is to go to Alignment, and if you want to wrap text, that's always a good idea. And that's under Text Control, and if there's a little minus sign here, it means it's not wrapping text. Click it, check mark. Now it will wrap the text. Thank you. Okay, so now I want to take the first part of my standard deviation equation, which is the x sub I minus x bar, and that simply is going to be F2 minus, and here it is a little different. You need to do the $F $15, and those dollar signs mean that each and every time it's going to take the value 17.59. And I see that for although that's I'm sorry, for Rhode Island, 15.5% of people who smoke, and that's 2.09% below the mean. Now I can just copy and paste that, and I'll have all of my numerator differences there. And so let's do paste. That's great. Now I want to square those terms, and here I'm going to go ahead and do Format, Cells, and I'm going, now you have to go back to number. I'm going to keep them as percentages, but I'm going to go out to 3 decimal points, and I think you'll see the logic of that. Remember, we're squaring proportions, which is squaring fractions, which makes fractions smaller if they're in many cases. So here we have, and it's simply G2, and then the shift 6 for the caret squared, and that tells me that I'm now at 0.044%. I can copy and paste these. Okay, and they are all relatively small. So then down here what I have, and I'll put it, I want to go ahead and sum them. And this is called the sum of squared errors, which which is kind of a funny name. And it's simply going to be equals to this sum from H2 to H13 colon H13. The next thing I want to do is take the quotient of that for my sample. And that would be equal to H15 divided by 11. Remember, we have 12 observations, but in a sample we use n-1, and that gives me the quotient is 0.173. And then if I want, my next step is to take the square root of that for the estimated standard error. So we can say it's the square root equals H17 to the 0.5. And I find that and so this is, let's go back up here. This is going to be a bit of a long term, but this is also then the standard deviation. 4.157%. Okay, so this is, and that seems a reasonable among these. If the mean is 17.5, if we were just sort of trying to eyeball them a little bit, you would notice that the highest observation is about 8 points higher than that at West Virginia at 25.7. The lowest is Utah at 9.1. So our range is around 16, and our standard deviation is around 4, centered around 17.5. So do we think most, if we look most, here's how many observations just very briefly fall within 4 points of 17.6? Well, you have South Carolina, South Dakota, Tennessee is just beyond it, Texas is within it, Vermont, all of the Virginia, Washington, West Virginia is beyond it. Wisconsin's almost right on the money, and Wyoming's very close. So you have, clearly about 9 of the 12 are within 1 standard deviation of the mean. If we want to test this, we can use the Excel command and simply say equals, and that's ST deviation. And this time I'm going to use the sample, and again, but here the sample we want is this, and what do you know, 4.157. So that concludes how you go about mechanically estimating a standard deviation. You should have sort of 3 working columns, which would be your initial data, and then your difference between each observation and the average of all the observations in your sample. Then you can square them. Then you take the sum of squared errors. Then you divide the sum of squared errors by the number of observations less 1 in the sample, or if it's a population, the number in the population. Then you take the square root of that, and it provides the standard deviation. Again, if you would do that for one of your 4 variables, that would be great, because then we'll move on to take care of it. You can use the Excel formula for the remaining 3. Once you have it down once, that's good enough, I think. But I do want you to see the mechanics of what a standard deviation looks like, and I thought that to shorten it a bit might help. Okay, so I hope that's helpful, and